Alright everybody, this is section 7.3, the law of cosines. What I really need you to do is take out your blue sheet. On the unit circle side, the law of cosine formulas are on the lower left hand portion, right by where the law of sine formulas are. And what we're going to do is we're going to use the law of cosines today, and we're going to have to memorize these. These are the formulas that you need to know or understand without any cheater sheet type of situation. The reason we need the law of cosines is every other time we've used the law of sines, it's two specific examples have happened. You have two angles and then a side across from the angle, or two sides and then one angle across from the side. So basically you are able to know something about an angle and a side of the same letter. But not always will this happen. So in this section you might be given all three sides, or you might be given two sides and the angle included, or essentially you do not know an angle and a side of the same formula or same letter. Okay, so these are the law of sines. It's the same formula over and over again, but basically if you're looking for a specific side, for instance side C, what you need to pay attention to in this formula is if you're looking for side C, the only angle you need is angle C, and then the other letters show up in those spots. So what I kind of recognize, or when I write down the formula, is I know I have to use A twice, B twice, and C technically twice. Okay, and the side that we're looking for, that's the angle. That's the only time I use C. And then it's A squared plus B squared, essentially the other two sides squared, added together, and then you subtract 2 times those two sides times the cosine of that angle. And then notice if I look for B, what switches? Now you have angle B. Okay, if I'm looking for A, you have angle A, and it's that process throughout the whole thing. What I'd really like you guys to do is write this down on your blue sheet. There may be an instance in which I need you to solve for an angle. So I basically need to get, cosine C by itself. Using algebra, how would you guys get this all by itself? Well, I'd hope you guys would all say subtract this one and subtract that one over. So I'm going to do that. Let's subtract it all over. And you'd end up with what? C squared minus A squared minus B squared equals negative 2 times A times B times cosine C. Okay, now how do you get cosine C all by itself? You would end up dividing out the negative 2AB, divide out the negative 2AB, and what you end up doing if you kind of manipulate this is I'd like to take this negative and give it to everything on top. So minus C squared plus A squared plus B squared all over 2AB equals cosine of angle C. And what we end up doing is we don't really want the negative up front. So if you solve for cosine C and do just a little bit of algebra or switch them around on top, notice what the only thing is that you subtract. It's the letter of the angle you're solving for. And then you take the cosine inverse of both sides and you end up getting C. What I want you to do is I want you to write this formula down on your blue sheet. Okay? Because now what you're going to do is if you solve for an angle, you can just dump this formula in if you want. Or you can just dump this in the formula and do algebra. We'll work on a bunch of these and I'll show you how to easily do this. But now you can interchange your letters and all that stuff as well once we use them. So let's actually use these and see what we do. So if I say solve for triangle ABC given this scenario. Alright, so I have A, B, C. Angle A is 60 degrees. Side B, so little b, is 20. And side C, that'd be this guy right here, is 30. And I want to solve for the triangle. Well, the only one that I know how to solve for, or the only one that I can get given this formula, okay, is I need to use the angle that I know, and I know angle A. So I'm going to use this bottom formula, and I'm going to try find side A. Alright, so let's do that. So dump it in. A squared equals, do I know side B and side C? I do. So it's 20 squared plus 30 squared. Then what? Minus 2 times those two side lengths we just talked about, times the cosine of angle A is 60 degrees. Alright, and now you just got to solve. So if you guys dump this in your calculator, and it's very important that you do these guys first and get a number, which is 1300 Okay? Then you're going to subtract that number, which is 600 if you multiply it out, and make sure your calculator's in degree mode. A squared then is equal to 700. Alright, and then you end up getting A is approximately 26.5. Okay, so that allows you to get your side. And it's really easy, it's that simple. There is no worry about having two answers or anything, just whatever you get is that answer. Okay, now how do I get to solve a triangle? I actually have to do something for all of them. Okay, I have to solve the whole works. So let's say I want to find angle B. This is what I was talking about on the previous slide, except now I want B there. So basically I need this B, and then I got to subtract B. And if you guys don't like doing that, okay, then you can dump it in one of these guys and solve for B. Alright, what I'm going to do is I'm going to dump it in as this. I want to find cosine of angle B, okay, and that's equal to, you add the other two letters squared, and you have to subtract the angle you're looking for, or the side letter of the angle you're looking for. All over 2 times, and then it's just the other two sides. Notice that the B's show up twice, A's show up twice, C's show up twice. It's no different than any other formula. And if you dump this in, I now know all of my sides. So I'm going to go 26.5 squared plus 30 squared minus 20 squared all over 2 times 26.5 times 30. So now if I finish this off, I got cosine B is equal to, and on the top I have 1202.25 divided by 1590, and that ends up being, once you take the cosine inverse of this fraction on your calculator, you will end up getting that B equals 40.9 degrees, and that's B. And that's quite sloppy, okay? But I know now that this is 40.9 degrees, just simply using the law of cosines again, and then finishing it off, you know that the last angle by default must add up to 180, so I know that angle C is 79.1 degrees. So angle B, 40.9, angle C, 79.1. And then you should always check these triangles out. Do they make sense? Is the largest angle with the longest side shortest or smallest angle with the shortest side? And as long as that happens, we should be happy. So let's move on and do one more. Alright, this one, this number 2, notice what I'm giving you. I give you all the sides. So we're going to have to do the formula, the cosine theta equals, basically solving for the angle twice this time. So let's just put in what we know. I'm just going to throw in a regular triangle. I don't really care how I label it or what I do. That doesn't really matter. Just know that wherever I deem my angle A, across from it, that's little a. It's 34. Angle B, across from it, it's little b, which is 20. Across from C is 18. And now what you want to do is solve for one of the angles. So that's kind of your call. Doesn't matter which one. Let's just try solve for C, because that's what I did the first time I showed you how to get this guy all alone. So let's put that formula on my paper. So cosine angle C is equal to. Now how does this work again? It's the other two sides squared added together. So I'm going to go the A, which is 34 squared, plus the B, which is 20 squared, and I subtract out the side of the corresponding angle that I'm looking for. So that's why I do the 18 squared. And that's the only time I use side C, alright, in this particular problem, because I'm looking for angle C. And that's all over 2 times, it's 34. The other two sides multiplied together. Okay? And what you got to do now is just multiply, or do your math on the top and do your math on the bottom, and then take your cosine inverse. So if you guys do that math, I'm going to try speed up just a little bit here. Your angle C will be 25.1 degrees. Okay? So take the cosine inverse of this number on top divided by the number on the bottom, and you will get 25.1 degrees. So I know that this side, this angle, is 25.1 degrees. Alright? Now, technically, and I'm sure some of you are wondering if you can do the law of sines again, and you can, if you, the law of sines, going back to what we did last week, but I'm going to talk about that in class. I want you guys just to practice this one again. If I want to find, for instance, maybe angle A this time, how does this formula change? Now I'm going to go cosine of A equals. How does the formula set up? All right. I need to do what? The other two letters, so in this case it's going to end up being the B, which is 20, plus the C, 18 squared, and I have to subtract the A squared. All divided by 2 times those first two numbers. I do not need to deal with A, so the 34 only shows up once. Okay? Once again, do the cosine inverse of this number on top divided by that number on the bottom. And if you guys go through that math on your calculator, it's 126.9 degrees. The benefit of the law of cosines is you do not have to worry about, is it one answer, is it two answers? I don't have to worry about the whole second triangle problem like we did with section 7.2 in the law of sines. The law of cosines will spit out the actual angle that is true based on our 3 sides. So that's the advantage of the law of cosines. Yes, it's a little more difficult, a little more math related, but you're able to do that. And then obviously to find your other angle, okay, these two and the third one must add up to 180. So to find angle B, it's 180 minus the 25.1, and if you minus the 126.9 as well, you'll end up getting that B is exactly 28 degrees. Alright? And now once you look at this, once again, it should work out. Alright? Smallest angle, smallest side. Middle, middle, largest, largest. And I should feel confident with my answers. Alright? So that's that. And now the last one, we're going to get back to these word problems that you guys absolutely loved back in chapters 2 and 3. Okay? So planes flying at an airspeed of 185 miles an hour with a heading of 120 degrees. For those of you that forget what a heading is, okay, that's from due north. Remember, these, it's based off of your North Pole. So it's due north going clockwise. So that would be 90 to there. I need to go a little bit farther. And I'm going in that direction. Okay? And this is going 185 miles per hour. And this is 120 degrees. And what you got to make the connection of is it's 90 straight across, so this little guy is 30 that will come into play. Alright? Wherever you end up stopping, okay, 185 miles an hour, the wind currents are going to push you one way or the other. So if you remember, what we did is we put a new set of crosshairs up, and I'm going to draw what my wind's doing. It's going 32 miles an hour at 165 degree heading. 165 degrees. Alright, that tells me that I'm going 90, but it's not quite 180. Okay, 165 degrees, and it's not quite as long. It's only 32 miles an hour. And that's where I'm going to end up. Okay, this is 165 degrees. Alright, so now what we got to do is figure out, what does it say? It says find the true course and the ground speed. So for those of you that remember what those two pieces of information mean, okay, ground speed literally means find that side, okay, and then the true course means because the wind's pushing us farther south, what is the actual course of the plane from its home base. So I actually need to end up finding the angle from starting spot all the way down to this red side, and we'll talk about that in a second. Okay? The easiest one to find straight out is the true speed. You need to find, essentially I'm going to call that x. If you can find this side, piece of cake. And using the law of sines, this is not hard, because if you have a side, and the angle between, we can use our law of cosines. So what you guys got to be able to do is, what is that angle in between? And that's the struggle that we got to find. And this isn't as easy as what it was before. This isn't a right angle anymore. Okay? What you need to make the connection of is whatever's left here. Okay, it was 165 degrees to there. That means whatever is left is actually going to be what? 100 and... what would be left? 360 minus that, like 195 degrees is left. So like there's 195 degrees in here, but I don't want the whole angle. I can get rid of this. I don't want that. That's not inside my triangle. Well, what is this angle? This angle corresponds with this information. Alternate interior angles. Okay? And this guy down here is 60 degrees because 120, 60's left. These two angles are the same. So that's my roundabout way to tell you guys that this angle inside here is 195 minus that 60 degrees. So it's 135 degrees in here. Alright, and gets quite messy. But why is that nice? Because now I can do my law of cosines and find my x. So I want to find x. X squared equals, okay? If you go back to your law of cosines formulas, it's going to be the other two sides. So 32 squared plus 185 squared. Alright? Minus 2 times those two sides again. And then cosine of 135. I hope you can see that on there. Okay? And now if you do your math, x squared equals, these first two guys is like 35,249 minus, and this is tricky, minus, and if you multiply those numbers all together, you're going to get a negative 8372, and two negatives make it positive. So if you add that together, x squared equals 43621 approximately. Take the square root and round to the nearest tenth. Your ground speed is 208.8 miles per hour. So that is the ground speed, just simply doing the law of cosines. Okay? The more difficult part to this is finding the true course. Okay? So going through this whole process, we know that the true course is 120 degrees plus whatever this little theta is in here. Okay? This angle. If I can find this angle, okay, it's a piece of cake. Now, do I have the ability to find this angle? Yes, because now I know all three sides. And we just got done doing the problem on the previous page for if you have all three sides, we can just manipulate our formula. So let's go cosine theta. I know I'm not calling it A, B, or whatever, but we just got to know what happens. Whatever the side is corresponding, so in this case the 32, that's the one you have to subtract. The other ones, you dump in as normal. So 185 squared plus the 208.8, the one you just found, squared, minus the 32 squared, all over 2 times the other two sides. Alright? Once you do all that calculation, take the cosine inverse, you'll end up finding that theta equals 6.5 degrees. Now why is that helpful? That is how much the wind is blowing you farther away from the home base. So in this case, the true course, because of the wind, it's 120 degrees plus this 6.5 degrees. So 120 plus the 6.5 degrees equals 126.5 degree true course. And that's what I would look for on a test or a quiz. So that's one example of our word problems. We definitely are going to be working on a bunch of those in class because I know they're not easy. This is the assignment we'll be looking at, and I hope you guys have a great day.